Chapter 10. Conclusion. We are not merely observers of the universe, we are participants in its creation. Time is a construct, a paradox that the mind needs to make sense of reality. To break free of it, we must understand the mind itself. So, fear not, there is no end, there is only the journey. Clovis, meditation and contemplation have long been associated with profound experiences of consciousness, introspection, and spiritual insight. While traditionally viewed as practices for personal growth and self-discovery, there is growing interest in exploring their potential connections to concepts in physics, particularly those related to higher dimensions, quantum phenomena, and the nature of time. In this summary, we'll delve into how meditation and contemplation may be linked to these concepts and explore the theoretical frameworks that underpin their potential connections. Meditation and contemplation are ancient practices found in various spiritual and philosophical traditions around the world. These practices typically involve quieting the mind, focusing attention, and cultivating awareness of the present moment. Through meditation and contemplation, individuals seek to explore the depths of their consciousness, gain insight into the nature of reality, and experience states of profound peace and clarity. The question arises, does consciousness travel to higher dimensions during meditation? In theoretical physics, higher dimensions refer to spatial dimensions beyond the familiar three dimensions of length, width, and height, as well as potential additional temporal dimensions beyond the one we experience as time. The concept of higher dimensions arises in theories like string theory and M-theory, which propose that the universe may contain additional hidden dimensions beyond those we perceive. One interpretation of higher dimensional frequency suggests that these additional dimensions may be associated with vibrational or oscillatory patterns beyond our perceptual range. While humans cannot directly experience higher dimensions, the mathematical frameworks of string theory posit that fundamental particles and fields may exhibit vibrational modes corresponding to the geometry of these higher dimensional spaces. The brain and quantum phenomenon. The brain, as a seat of consciousness, remains one of the most intriguing and least understood aspects of human physiology. Neuroscientists have made significant strides in understanding the neural correlates of consciousness, exploring how patterns of neuronal activity give rise to subjective experiences and cognitive processes. At the same time, quantum mechanics, the branch of physics that describes the behavior of particles at the smallest scales, introduces a new layer of complexity to our understanding of the brain. While the exact role of quantum phenomena in brain function remains a topic of debate, some researchers have proposed hypotheses suggesting that quantum processes, such as quantum coherence and entanglement, may play a role in neural dynamics and information processing. Time, basics in physics, quantum mechanics, and string theory. Time, as we perceive it, is intimately connected to our experience of reality and the unfolding of events in the universe. In classical physics, time is treated as a linear progression from past to present to future, forming the backdrop against which physical phenomena occur. However, the nature of time becomes more complex and nuanced in the realms of modern physics, quantum mechanics, and string theory. Quantum mechanics, the fundamental theory governing the behavior of particles at the quantum level, introduces the concept of superposition, where particles can exist in multiple states simultaneously. Additionally, quantum entanglement suggests that the properties of particles can be correlated in ways that defy classical intuition, leading to non-local connections between distant objects. Meditation and dimensional time shifting. The potential connection between meditation and dimensional time shifting lies in the exploration of altered states of consciousness and the transcendence of conventional perceptions of time and space. Through meditation and contemplation, individuals may enter states of heightened awareness, where the boundaries of the self, time, and the external world dissolve, and the experience of time becomes fluid and malleable, while the precise mechanisms underlying meditation-induced dimensional time-shifting remain speculative. Some hypotheses suggest that the practices of meditation and contemplation may facilitate shifts in consciousness that allow individuals to access higher states of being. In these states, the linear progression of time may give way to a more holistic and interconnected understanding of reality, where past, present, and future coexist in a timeless continuum. In summary, the exploration of meditation, contemplation, and their potential connections to temporal dimensions, quantum phenomena, and the potential for time dilation or movement represents a fascinating intersection of science, philosophy, and spirituality. While the exact nature of these connections remains speculative and subject to ongoing research and debate, the exploration of altered states of consciousness and the transcendent experiences they afford offer profound insights into the nature of reality and the human experience. As our understanding of the brain, quantum mechanics, and theoretical physics continues to evolve, so will our exploration of the mysteries of consciousness, time, and the universe, learning from another time dimension that you will not physically go to, meaning you're extracting information from a potential future or past without interacting with or affecting that timeline raises interesting questions about causality. Let's see whether this would violate causality in different frameworks of time and physics. 1. Understanding causality. In its simplest form, causality is the principle that cause precedes effect. In classical physics, this means that an action in the past can affect the present or future, but not the other way around. Even in relativistic and quantum frameworks, causality ensures that no information or influence can travel back in time to change past events, preserving the arrow of time. 2. The nature of time dimensions in TST. In temporal-subjection theory, TST, time is thought to consist of multiple dimensions or temporal time dimensions, TTD. The key idea is that there are many potential timelines or futures that consciousness can navigate. Some of these dimensions may represent alternate realities, while others could represent potential futures that you can either choose to enter or not. 3. Observing or learning from another time dimension. If you're learning or observing information from another time dimension, such as a potential future or an alternate timeline, and you do not interact with it or enter that dimension physically, the main question becomes whether this transfer of information affects causality in your current timeline. Key considerations are: A. No physical interaction. If you do not physically interact with the timeline from which you're extracting information, you are not causing any direct changes to that timeline. In this case, you are essentially passively observing information from another dimension without interfering with the events there. Since you're not physically entering or altering the events in that dimension, this would not violate causality in that timeline. B. Information transfer across dimensions. The act of receiving information from another dimension could be viewed similarly to learning about a potential outcome or receiving a prediction about the future. C. Causality in your dimension. In your current dimension, causality remains intact as long as the information you receive doesn't violate the cause-effect relationship in your timeline. For example, if you learn about a potential future event and use that information to make decisions, this doesn't violate causality because it happens in your timeline and follows the natural progression of cause and effect. D. No backward causation. The key to preserving causality is ensuring that no information or influence travels backward in time to affect the dimension from which you learned the information. As long as information flows forward, causality is preserved. Let's do a comparison with time travel. Time travel often introduces causality problems, such as the grandfather paradox, where changing an event in the past creates inconsistencies in the present, or future. However, in this scenario, you are not traveling physically to another timeline or time dimension. You are not changing events in the alternate dimension. Therefore, you avoid most of the paradoxes that would arise from time travel. 4. The role of information and causality. In quantum mechanics, information plays a critical role in how systems evolve. There are several key frameworks that relate to causality and information. Transfer, quantum information. In quantum mechanics, the transmission of information is often subject to strict limits, such as the no-signaling theorem, which states that information cannot travel faster than the speed of light, preserving causality. In the case of quantum entanglement, for instance, although measurements are correlated instantaneously, no usable information is transmitted that can violate causality. Quantum observation, if you're learning from another dimension, is akin to quantum observation, where you're simply gaining knowledge about the state of a system without changing it. Then this observation doesn't violate causality, even in quantum frameworks, as long as there's no backward flow of information that changes the past. Causality remains intact. 5. Causal consistency in a multidimensional framework. In speculative frameworks like TST, or in theories like the many-worlds interpretation of quantum mechanics, multiple dimensions or timelines can exist simultaneously. Each dimension or timeline can have its own internal consistency and causality. A parallel dimensions. If each timeline is parallel and doesn't interact with the others, then learning from one timeline doesn't affect the others. The causality in your timeline is preserved because the flow of cause and effect remains consistent in your dimension, regardless of the information you acquire from another dimension. B. Accessing potential futures. If you're observing potential futures in one dimension and making decisions in your current dimension based on that knowledge, this would not violate causality. You're simply using information about possible outcomes to guide decisions, which follows the natural causal flow. 6. Philosophical implications of learning from other dimensions. From a philosophical standpoint, if multiple realities or dimensions exist, causality can be preserved within each dimension as long as actions in one dimension don't alter events in another. This means that learning from another dimension doesn't change the past or present in that other dimension. Causality preserved there doesn't disrupt the causal flow in your own timeline. Causality preserved here. Learning from another time dimension that you will not physically go to does not violate causality as long as the following conditions are met. No physical interaction occurs with the timeline from which you are extracting information. Information flow is consistent with the forward progression of time, meaning no information is transferred backward in a way that would affect the past of the observed dimension. Causality in your dimension remains intact because you are simply acquiring knowledge and using it to influence decisions in a way that follows the natural cause-effect relationship in your timeline. In this framework, causality is preserved because the act of observing or learning from another time dimension is passive, and no changes are made to either the observed dimension or your own. The flow of information doesn't inherently violate the laws of causality as long as it adheres to these principles. This paper provides a broad overview of the complex and multifaceted relationship between meditation, contemplation, and the theoretical frameworks of modern physics, focusing on string theory and using quantum mechanics to explain superposition. We can start to form our reality. We know our reality is subjective, and our experience is subjective. Also, other dimensions exist, with temporal dimensions forming our perception of time. Superposition could allow for entanglement of our consciousness with another temporal dimension, not yet passed through like in the growing block universe. Meditation and rhythmic vibration techniques can be used to help our brain frequency shift, or attune to a higher dimensional time frequency, and entanglement could link our consciousness to it. This, along with conscious thought projection in meditation, could help shift you from one temporal time dimension to another desired temporal time dimension, allowing you insights and effectively changing your perceived future in your perceived timeline.